Hi, fourth grade. This is Miss K, and we are on Unit 5, Lesson 4. And we're going to read about earthquakes and tsunamis today. So here's some vocab for you. An eyewitness is a noun, and it's a person who has seen something happen and can describe it. So they were there, they witnessed it. Experiment is a noun. We know what that is, a scientific test to try something out. Fault is a noun, and that is a crack in Earth's crust. Heave is a verb, to move up and down over and over, or it could also mean to lift, pull, push, or throw with a lot of effort. Trigger is a verb, and that means to cause something to start or happen. Pinpoint is a verb, and that is to figure out the exact location. Magnitude is a noun, and that is an earthquake's strength. An aftershock is a noun, a smaller, weaker earthquake that often follows a main earthquake event. A tsunami is a gigantic wave of seawater caused by an earthquake in the oceanic crust. And then surge is a verb, and that means to move forward quickly, suddenly, and with force. So chapter 3 is called Earth's Shakes and Quakes, and our big question is what happens beneath Earth's surface to cause earthquakes? Italian writer Francesco Petrarch penned the following eyewitness account in the Middle Ages. Can you guess what he was writing about? The floor trembled under my feet. When the books crashed into each other and fell down, I was frightened and hurried to leave the room. Outside, I saw the servants and many other people running anxiously to and fro. All their faces were pale. If you said an earthquake, you are correct. People in northern Italy had a good reason to be pale and frightened on a winter's day in 1348 CE. On that day, a large earthquake struck. Thousands of people lost their lives. Earthquakes are violent natural disasters that strike without warning. Suddenly, the ground begins to shake, furniture topples, objects tumble from shelves, and buildings may even collapse. In 1348 CE, people had no idea what caused earthquakes. Today we know that earthquakes are the result of powerful natural forces at work in Earth's crust and mantle. As you read in chapter 2, scientists developed the theory of plate tectonics in the 1960s. The theory explains how Earth's surface and interior changed over very long periods of time. Some plates are pulling apart at their boundaries, other plates are colliding, and still some are sliding past each other. A lot happens at plate boundaries, including most earthquakes. In fact, one of the easiest ways to locate a plate boundary is to determine where the earthquakes are coming from. So this is showing all of the different spots where plate boundaries are and past earthquake epicenters. So you can see all of the colors are where those boundaries are happening between the two plates, and that's where the earthquakes are starting from. Forces and faults. Try a little experiment. Extend your arms out in front of you, parallel to the floor, and press your hands together. Keep your palms and fingers flat against each other. Now start pressing your hands together and gradually increase the pressure. When you can't press any harder, let your right hand slide forward. That sudden slipping is what happens at a fault. So push your hands as close together as you can and then slowly push it forward and you see that they just slide right past. A fault is a fracture or a crack in Earth's crust. Most faults occur along the boundaries of tectonic plates. As the plates move, huge, rough blocks of rock along either side of a fault get stuck against each other. Beneath the plates, however, material in the mantle keeps moving. This material exerts more and more pressure on the plates to also keep moving. Pressure builds along the stuck edges of the fault. Think of your hands as these edges pressing harder and harder together. The pressure builds until the stuck blocks of rock suddenly break and slip past one another. As they do, a tremendous burst of energy is released. How much energy? Well, all the energy that accumulated in the rocks during the time they were stuck and couldn't move. The Pacific Plate is Earth's largest tectonic plate. It lies beneath the Pacific Ocean. Imagine how much energy it takes to move that gigantic rocky plate plus all the water on top of it. Then imagine all that energy being released at a fault in just one moment. Such a colossal burst of energy travels outward from the fault in all directions, known as seismic waves. These make the ground heave and shake, and this violent shaking is what we call an earthquake. The San Andreas Fault. In the United States, one of the most famous faults is the San Andreas Fault in California. It lies along the boundary between two tectonic plates that are slowly moving past each other. The movement, however, is far from steady. For years at a time, blocks of rock bordering the San Andreas Fault stay stuck. Pressure slowly builds, and then wham, they slip and trigger an earthquake. The 1906 San Francisco earthquake was one of the worst in American history. The sudden slip that triggered it was huge. It caused rocks on either side of the fault to move more than 20 feet in just seconds. And you can see here some of the effects of the earthquake. So our fence broke. You can see some houses in the back. The roofs were a bit collapsed. Shake, heave, sway, and lurch. All earthquakes begin with huge blocks of rock moving along faults. The place in Earth's crust where this happens is an earthquake's focus. Think of it as the earthquake's heart, the source of the seismic waves. The focus may be deep in the crust or close to the surface. The epicenter is the point on Earth's surface directly above an earthquake's focus. Some kinds of seismic waves produced by earthquakes travel deep into the Earth's interior. Surface waves, however, are seismic waves that are first noticeable at the epicenter. During an earthquake, surface waves are what makes the ground shake, heave, sway, and lurch. They are the cause of most earthquake damage. In Chapter 2, we read about seismographs, which scientists use to record the shaking of Earth's surface caused by seismic waves. The time it takes for seismic waves to reach a seismograph is important in determining where the earthquake occurred. The longer the seismic waves take to reach the seismograph, the further away the earthquake is. So this is a great image showing us the place in the Earth's crust where an earthquake begins is its focus. So this is where it began. The epicenter is directly above it on the crust. So this is where the hardest hit is going to be. All right, this is talking about seismographs now and then. So we have modern seismographs, which record the shaking of Earth's surface caused by seismic waves. A seismogram is the record a seismograph makes. And it shows jagged up and down lines. Scientists compare multiple seismographs in order to pinpoint an earthquake's epicenter. So they use more than one just to make sure they know exactly where it is. And this is an older version. This was around 132 CE. It looks nothing like a modern seismograph. It was not as accurate and not as high-tech as the ones we have today. So the ones we have today are much more accurate. We can pinpoint exactly where the earthquake started. Measuring an earthquake's strength. Scientists also use seismographs to measure an earthquake's strength or magnitude. During a small earthquake, Earth's surface may shake only a little. The seismograph shows these relatively low-energy seismic waves as little wiggles. During a big earthquake, Earth's surface shakes a lot harder. The seismograph shows these high-energy waves as big zigzags. The Richter scale is another way scientists measure an earthquake's magnitude. The Richter scale assigns a number to an earthquake based on the largest seismic wave recorded for that earthquake. The higher the Richter scale number, the stronger the earthquake. For example, a magnitude 5.0 earthquake on the Richter scale causes 10 times much ground shaking as a magnitude 4.0 earthquake. So a 6.0 is 10 times more than a 5.0, and so on. So the higher the number, the more damage caused. And here is some more damage caused by earthquakes. The modified Mercalli intensity scale uses numbers to measure earthquake strength. So this is just another way that they measured it, is this scale right here. And this is the new scale, and this is the Richter scale and how they line up. Pressure along faults can build up for years, even centuries. When blocks of rock along a fault finally move, the resulting earthquake happens very quickly. Most earthquakes last just a few seconds. Still, the trouble may not be over after the ground stops shaking. Large earthquakes are often followed by aftershocks. Aftershocks are like mini earthquakes. They are usually smaller and weaker than the main earthquake event, and they happen as blocks of rock along the newly slipped fault settle into place. Earthquakes at sea. Remember that most earthquakes occur along the boundaries of tectonic plates. Several plate boundaries are in the ocean, so many earthquakes occur in the oceanic crust that forms the seafloor. This is especially true around the Pacific Ocean. The Pacific has many deep ocean trenches along the edges of its ocean basin. Ocean trenches form when one tectonic plate is sliding or subducting beneath another plate. Earthquakes are very common in the continental crust along ocean trenches. Earthquakes that occur in the crust forming the ocean bottom can cause the seafloor to shift. This shift can cause seawater from the ocean bottom to its surface to suddenly start to move. The result is a gigantic wave called a tsunami. Tsunamis travel fast, as much as 500 miles per hour. Out in deep water in the middle of the ocean, you'd hardly notice this great pulse of water passing by. All that water piles up as the tsunami approaches a coastline. It becomes a towering wall of water that may be as tall as a 3 or 4-story building. The tsunami crashes onto the shore with incredible force. It surges far inland. Then it goes roaring and churning back out to sea. Tsunamis can cause terrible destruction. Okay. The first one gives you a sentence. It uses the word penned, and it wants to know, what does it mean? Number 2, go back to page 22 and tell me, what words does the author use to describe an earthquake? Why are plate boundaries important? Blank are the places where earthquakes start from. Remember, look at that picture that showed us in the text. Number 5, what effects of the 1906 San Francisco earthquake do you see in the image on page 25? So go back up and look at the image. What effects do you see? Why do you think the author compares the earthquake's focus to a heart? True or false, scientists only use one seismograph to find an earthquake's epicenter. Number 8, how are the first and the modern seismographs similar? Number 9, the blank scale helps scientists measure earthquakes. Number 10, an earthquake and an aftershock are the same thing, true or false? And number 11, an earthquake in the ocean triggers a blank to occur. All right, that is your reading. Let's head over to skills. Number 1 is a review from the reading we just did. What happens beneath Earth's surface to cause earthquakes? So in your own words, when an earthquake happens, what's going on underneath the Earth's surface? Number 2, fault means a crack in the Earth's crust. What part of speech is that? A noun, an adjective, a verb, or an adverb? And for the next few, you're going to choose the correct meaning of the word fault. So fault can mean a crack in Earth's surface, and it can also mean responsibility for wrongdoing. So if something is my fault, it's my responsibility. I did something wrong. So you're going to read the sentence, and you're going to pick. Does that version of fault mean a crack in Earth's surface, or does it mean that someone is responsible for something wrong? So the first sentence, it was my fault that we missed the train because I overslept. One of the most famous faults in America is the San Andreas Fault in California. She blamed herself for the dog running away, but it wasn't anyone's fault. Most faults occur along the boundaries of tectonic plates. When energy is released at a fault, it triggers an earthquake. His mother punished him for breaking a glass, even though he said it was his brother's fault. And the last 2 questions, we're going to review these commas again. So remember, we use commas when we're doing a short pause, when we're writing a list, when we're writing dates, or when we're writing cities and states. So the same thing, you're going to rewrite these sentences, so you can go ahead and copy this if you want. So right-click copy, right-click paste, and then add in the commas where they belong. And that is all for today. Have a wonderful rest of your day. I'll see you next time. Bye, Adams.